Okay. Here's a much harder one. Or not harder one, but it's something that could happen. Here, I forget which group was treated and control, but if we take the difference between the treated and control, we get a massive effect, right? But then if we adjust for x, right? If we adjust for x, then there's no effect, right? There's absolutely no effect, right? Because the line for the blue guys and the line for the red guys, assuming they're parallel, and regardless of whether they're assumed to be parallel, their difference in intercept is going to be very small. Another thing to point out on this one, there's almost no overlap. There's almost no direct comparison of the treated and untreated group at a specific value of x. If you hold x constant at any value, you don't have any both red and blue dots, right? You only have blue dots or red dots, which means these groups aren't terribly comparable, right? So this this effect, which disregards x, if x is an important confounder, that has the problem of disregarding x, and it obviously gives you a tremendously different effect than if you incorporate x. But even if you incorporate x, there's a problem in that the groups aren't terribly comparable. The estimate is all model; it's no data. Okay, this for the blue people, because there's no data to inform it, it could go like that, and for the red people, it could go like that, whatever, and you could get whatever effect you want, even absence of any sort of meaningful treatment effect. Okay, so let's discuss this now. So the x variable in this case is highly related to group status in this case, right? Just if I told you x, you would know what group you were in. If it was a low x, you'd be in the blue group, and if you were a high x, you would be in the pink group. The variable x is related to y, but the intercept doesn't appear to depend on the group variable, of course, but we have no data to evaluate the impact of the, for example, in the pink group, we don't have any data near the intercept, so everything is dependent on the model. So the x variable remains related to y, holding group status constant. Let's see some other points. So the group variable is marginally related to y disregarding x. That just means that those marginal means are hugely different if we disregard x. Let's see. And I think I should have expanded on this point right here, that the x variable remains related to y, holding group status. So that what I mean by that is if you look just at the blue group, it appears to be linear and linear and related to y. And if you look at just the pink group, it appears linear and just linearly related to y. Okay. So this model, right, under the adjustment effect, would have a huge marginal effect, but no adjusted effect. And then, as I said, there just isn't any data to inform this relationship between the group and y for after adjustment. The conclusion is entirely based on the model. Okay, so that's another. So we've gone 2 examples, just changed things very mildly. And the code for this you can get from the Slidify thing. I'm not going to show the code every